Unit 2 Light Energy. Lesson 1 Mirrors. Light reflection. What's meant by light reflection? It is the phenomenon of light bouncing off or returning back in the same medium when it meets a reflecting surface. Reflection of light is governed by two laws. The first law is angle of incidence is equal to angle of reflection. If we have a plane mirror and we have an incident light ray, it will be reflected. If we draw the normal from the point of incidence, we will have four angles. We are interested in this angle, the angle between the incident light ray and the normal, which is the angle of incidence, and the angle between the normal and the reflected light ray. As you can see, they are equal to each other, equals 60. If we have another incident light ray with different angle and we draw the normal, we will see that the angle of incidence will be equal to the angle of reflection, equal 40. So the first law of light reflection states that angle of incidence is equal to angle of reflection. The second law states that the incident light ray, the reflected light ray, and the normal to the surface of reflection at the point of incidence all lie in one plane perpendicular to the reflecting surface. Note the following. The relation between the angle of incidence and the angle of reflection can be represented by the following graph because they are directly proportional and they are equal in measure. Concepts concerning reflection of light. What's meant by the incident light ray? It is the light ray that falls on the reflecting surface, this one. What's meant by a reflected light ray? It is the light ray that returns back from the reflecting surface. Angle of incidence. Angle of incidence, it is the angle between the incident light ray and the normal. Angle of reflection. It is the angle between the reflected light ray and the normal. Give reasons for the incident light ray that falls perpendicular on a reflecting surface reflects on itself. This is because the angle of incidence equals the angle of reflection equals 0. Types of mirrors. We have two types of mirrors. The first one is plane mirror. The second one is spherical mirrors. But we have two types of spherical mirrors: convex mirror and concave mirror. First, we will talk about plane mirrors. What's meant by plane mirror? It's a piece of plain glass painted from behind with a thin layer of silver metal. To give the glass a bright surface, reflects most of the incident rays on it. The properties of the image formed by a plane mirror. The image is upright or erect, as you can see from this image. The image is equal to the object in size. This is the height and width of the image, which are equal to the height and width of the object. So the image is equal to the object in size. The image is laterally inverted or reversed. This is the left hand of the object, but This is the right hand of the image. The image is laterally inverted or reversed. The image is virtual, which means you can't receive it on a screen. The image cannot be received on a screen. It is inside the mirror. The next property is the distance between the object and the mirror, which is represented by this red line, is equal to the distance between the image and the mirror, which is represented by this blue line. The final property is that the straight line joining the object to its image is perpendicular to the surface of the mirror. This straight line, which joins between the object and its image, makes an angle of 90. The word ambulance is written in a converted way on the ambulance card. In order to appear in the mirrors of the cars in front of the ambulance car, written in a correct way and can be read by the drivers. Let's talk about the second type of mirrors, which is spherical mirrors. What's meant by spherical mirrors? Spherical mirror is a mirror that its reflecting surface is a part of a hollow sphere. We have two types for spherical mirrors. The first one is concave mirror. The second one is convex mirror. Let's talk first about concave mirror, and it has a second name, which is converging mirror. What's meant by concave mirror? It's a mirror in which its reflecting surface is a part of the inner surface of the sphere and converges and collects the light rays after reflection. This yellow surface represents the reflecting surface of the concave mirror. As you can see, it is the inner part of the sphere. So this mirror is a concave mirror. Some concepts related to concave mirrors. Center of mirror curvature of concave mirror. As you can see, this center represents the center of the sphere, from which this mirror is considered part of it, and it is also the center of this mirror. So what's meant by center of mirror curvature? It is the center of the sphere that the mirror is considered a part of it, and it lies in front of the reflecting surface. This is the reflecting surface of the concave mirror, and the center lies in front of it. This is the center of mirror curvature. The second concept is radius of mirror curvature, R. As you can see from this representation, this line segment is called radius, just like in geometry. What's meant by radius of mirror curvature? It is the radius of the sphere that the mirror is a part of it. Or we have another definition for radius. It is the distance between the center of mirror curvature and any point on its surface. So the mirror has uncountable number of radii. The next concept is pole of the mirror, P. It is the point that is in the middle of the reflective surface of the mirror. The point which is considered the midpoint of the surface of the mirror is called pole of the mirror. This point is called pole of the mirror. The next concept is principal axis of the mirror. What's meant by principal axis of the mirror? It is the straight line that passes by the pole of the mirror, P, and its center of curvature, C. This straight line is called the principal axis of the mirror. Secondary axis of the mirror. It is any straight line that passes by the center of mirror curvature and any point on its surface except the pole of the mirror. Focus of the mirror, F. It is produced when a parallel beam of rays is incident parallel to the principal axis of a spherical mirror. Focus of the concave mirror. It is the point of collection of the reflected light rays, and this focus is real. You can receive it on a screen. As you can see here, this is the principal axis, and if we have incident parallel rays to the principal axis, it will reflect passing through focus. The point of collection of the reflected light rays will be collected in a point which is called focus, and this focus is real in case of concave mirror. The last concept is focal length of the mirror, F small. Focal length of the mirror, it is the distance between the focus of the mirror and its pole, and hence focal length equals half the radius, and the radius of mirror curvature equal twice the focal length. Types of images. We have two types of images. Real image, as you can see, here we have a concave mirror and we have a candle. This candle represents the object, and this is the image of the candle. And as you can see, the image is inverted, and you can receive it on a screen. So this image is a real image. What's meant by real image? It is the image that can be received on a screen, and it is always inverted. The second type of images is virtual image. It is the image that cannot be received on a screen, and it is always erect, upright. Let's talk about rules that we will use to determine the direction of the reflecting light rays incident on the concave mirror. The following rules will be used to draw the ray diagram to find the image and its properties. Case 1. If the incident light ray falls parallel to the principal axis, it reflects passing through the focus. So if we have an incident light ray parallel to the principal axis, it reflects passing through the focus. Case 2. If the incident light ray passes through the focus, it reflects parallel to the principal axis. So if the incident light ray passes through the focus, it reflects parallel to the principal axis. The last case, if the incident light ray passes through the center of mirror curvature C, it reflects back on itself. Give reason 4. The light ray that passes through the center of mirror curvature, it reflects on itself. If we use the protractor after drawing the tangent, we will see that this ray will make an angle 90 with the tangent to the point of incidence. So this light ray will reflect on itself because it falls perpendicular to the spherical mirror. So its angle of incidence is equal to the angle of reflection equals 0. Steps of drawing a concave mirror. Step number 1. Draw a spherical surface and determine its center by using a compass. I suggest that you open your compass with radius equals 6 cm. And by drawing an arc representing the concave mirror and putting dashes that cover its outer surface, which represent the layer of silver. The second step is to draw the principal axis and determine on it the position of focus, which is equal to half the radius. So by using your ruler, putting the focus after 3 cm from center of mirror curvature or from the pole of the mirror. So the distance between C and F is 3 cm and between F and P is 3 cm. Step number 3. Draw a vertical arrow on the principal axis to represent an object. Step number 4. Draw a ray from the highest point of the object where it falls parallel to the principal axis and thus reflects passing through the focus. Step number 5. Draw another ray passing through the focus of the mirror, then reflects parallel to the principal axis. From the same point, we will draw a straight line passing through the focus. It will reflect parallel to the principal axis. Step number 6. Determine the position where the two reflected light rays meet, which is the image of the highest point of the object. This is the first reflected light ray and this is the second reflected light ray. They are intersected at this point. This point is the image of the highest point of the object. Step number 7. Determine the position and properties of the image formed. As you can see, after drawing all steps, this point represents the position of the image. By drawing the image, now you can determine its position, and as you can see, the image is formed between C and F. What is the properties of the formed image? The image is real. This means that you can receive it on a screen. The image is inverted. The image is smaller than the object. Now we can draw the images formed by concave mirror. Formation of the images by the concave mirror. Case number 1. In the exam you will be given the position of the object. Object is very far. First of all, we will bring our compass and by using it we will draw an arc of radius equal 6 cm. By using the ruler, we can put the focus after 3 cm from the center of mirror curvature. The object is too far, so we have incident parallel rays parallel to the principal axis. It will reflect passing through the focus. So as you can see, the two reflected light rays are intersected in focus. Position of image is at the focus. Properties of the image is real, very tiny, or dot. This is the image of sun. Case 2. If the object is at a distance greater than the radius of curvature after the center of curvature. This is the radius of curvature from P to C. The object is at a distance more than the radius, so you can put it in any place after C. I suggest that you draw this object of length 2 cm, or if you using your copybook, the length of this object will be 2 lines in your copybook. We will draw a parallel incident light ray. It will reflect passing through the focus. We will draw another ray passing through the focus. It will reflect parallel to the principal axis. The point of intersection is the position of the image. Position of the image, as you can see, between C and F. Properties of the formed image is real, inverted, and smaller than the object. Case 3. Object is at the center of curvature, or at a distance equals to the radius of curvature. At C, we will draw 2 incident light rays from the highest point. The first one is parallel to the principal axis. It will reflect passing through the focus. The second one will pass through the focus, and it will reflect parallel to the principal axis. As you can see, the image is formed at the center of mirror curvature. Properties of the image are real, inverted, and equal to the object. Case 4. The object is between the focus and the center of mirror curvature, or at a distance more than the focal length but less than the radius of mirror. So the object is between C and F. We will draw 2 incident light rays from the highest point. The first one is parallel to the principal axis. It will reflect passing through the focus. The second one will pass through the focus. It will reflect parallel to the principal axis. The point of intersection of the 2 reflected light rays will be the position of the highest point of the object. So the image is formed at a distance more than the radius of curvature, or after C. Properties of the image is real, inverted, and enlarged, or you can say magnified. Case number 5. Object is at focus at F, or at a distance which is equal to the focal length. We will draw parallel incident light ray. It will reflect passing through the focus. The second one will pass through the center of mirror curvature, so it will reflect on itself. As you can see, the 2 reflected light rays will not never intersect because they are parallel to each other. So no image is formed. Case number 6. If the object is located between the focus and the pole of the mirror, or at a distance which is less than the focal length. By drawing the incident light ray parallel to the principal axis, it will reflect passing through the focus, and the second ray will pass through the center of mirror curvature, so it will reflect on itself. By drawing the extension of the 2 reflected light rays, extensions will be intersected at a point. This is the position of the image. So in this case, the image is formed behind the mirror. And as you can see, the image is virtual. That means that you can't receive it on a screen. The image is erect or upright. Also, the image is magnified or enlarged. What are the uses of concave mirror? It is used as a torch to reflect light. Also, it is used in front lights of cars to reflect lights. It is used in shaving to get an enlarged and erect image of the face. But in this case, this man must stand at a distance less than the focal length to get this image. Because if this man stands at a distance more than the focal length, his image will be inverted. Also, concave mirrors are used in marine lighthouses that are found at marine ports to guide ships. Also in aircrafts landing at airports to guide aeroplanes. In solar ovens to collect a large amount of the solar energy in the focus of the mirror for cooking foods or melting metals. So this container must be placed at the focus of this mirror. Let's talk about convex mirror, or it is called diverging mirror. It is called diverging mirror because it diverges light. It separates light. What's meant by convex mirror? It is a mirror in which its reflecting surface is a part of the outer surface of the sphere, and it diverges. It separates the light rays after reflection. This yellow part represents the reflecting surface of convex mirror, and as you can see, it is the outer surface of the sphere. Some concepts related to convex mirrors. They are similar to that for concave mirror, but I will mention only the ones that contains differences between concave and convex mirrors. Center of mirror curvature of convex mirror. It is the center of the sphere that the mirror is considered a part of it. But the difference is here. And it lies behind the reflecting surface. As you can see, this blue surface represents the reflecting surface of convex mirror. The center is behind it. It was in front of the concave mirror, but in our case, it is behind the reflecting surface in convex mirror. Focus of the mirror. It is produced when a parallel beam of rays is incident parallel to the principal axis of a spherical mirror. Focus of the convex mirror. It is the point of collection of the extensions of the reflected light rays, and hence it is virtual because it is resulted from the intersection of the extensions of the reflected light rays. If we have a spherical mirror and its reflecting surface as the outer surface, so we have convex mirror, and we have a parallel incident light rays. They will be reflected by the mirror and their extensions will be collected at the focus, and hence this focus is virtual. Image formed by the convex mirror. We will deduce the properties of the formed image by convex mirror. As you can see, the center here is behind the mirror. If we have an object which is placed in front of the convex mirror and we have an incident parallel light ray, it will be reflected by the mirror and its extension will pass through the focus. If we have another ray passing through the center of this mirror, it will reflect on itself. This point of intersection is the position of the image, and as you can see, the image is formed behind the mirror. The image is virtual, erect or upright, and small. So wherever the position of the object in front of the convex mirror, the image is virtual, erect, and small. Uses of convex mirror. Convex mirror is used as a side view mirror on the passenger's side of a car. This is because it forms an erect and smaller image for the whole road behind the car. It is suitable for a convenient shop and big supermarket and any other corner where need anti-thief. It is used in the turning of the road, parking, and metro. This is the end of lesson 1. Thanks for watching.